Hello everyone, my name is Uday and I am here today to present my final project for our course Discovery and Learning with Big Data. This is a comprehensive application of data science spanning strategic planning and the execution of diverse machine learning modeling techniques. Here in my second slide, I have structured this presentation into 15 slides and I will begin with high level ML strategy for a firm, which is an overview of the strategic framework for implementing machine learning across an organization. Then I transition into three distinct case studies which are the task for of a code given by our professor. The part 2, Austin Animal Shelter data pre-processing, which is detailed examination of the data steps I took to prepare that data set. Then part 3, Avalon regression model, where I explored a regression model to predict Avalon age based on physical measurements. And then part 4, car evaluation clustering, which involved an analysis of the clustering approach used to segment cars. And then the final part 5, adult income classification, a classification model aimed at predicting income levels based on demographic features. I will conclude with a brief model comparison and key insights for the future work derived from my project. And as we all know, we had to submit final project report of our work given by professor. So I'll just shortly show you my report work that I have done. Here you can see starting from part 1, where strategy to employ machine learning in a firm, then all the remaining codes, important parts, and the code I have generated for data cleaning, pre-processing, and model training, execution, evaluation, k-cross, and everything I have reported over here, as you can see. Moving on to next slide. The part 1 will be ML strategy for a firm, an overview of the strategic framework for implementing machine learning across organization. Then the 3 codes that I have performed for different regression model clustering and classification, starting with ML strategy overview. This part establishes the strategic framework. My primary goal is to define strategy for company-wide machine learning deployment. The objective is to integrate machine learning into the core operation of a company over a 3-year timeline, ensuring all departments benefit from data-driven insights. And the context for this strategy is a large competitive firm. I am designing this for a well-funded organization in a competitive sector such as finance or e-commerce, where leveraging data provides a significant advantage. As we all know, in today's generation, data is everything. And the core Yeah, so the core approach I propose is the hub and spoke model. This model facilitates a centralized hub for machine learning resources and governance while allowing individual departments to operate autonomously, fostering innovation and tailored solutions for their companies. In this slide, I'm going to show strategy pillars. The execution of this comprehensive strategy rests on three equally critical pillars: people and culture, data and governance, platform and technology. First one, people and culture. This is about human capital, fostering a culture of innovation through talent acquisition, continuous learning, and promoting machine learning literacy across the organization. Second one, data and governance, establishing a robust data governance framework is critical to ensure high quality, secure, and accessible data alongside responsible AI practice. So in that case, nobody can misuse the company's data or breach the privacy policy or customer's profile. The third one, platform and technology, building. This is focusing on building a scalable and secure MLOps ecosystem that supports the full life cycle of machine learning models, deployment, monitoring, and management. To execute the strategy pillars discussed in the previous slide, I have focused the plan in two key areas. The first one would be ML Ops platforms, and the second one will be human capital. In this ML Ops platforms, my technical plan is to implement a centralized feature, store and manage training environments. This is essential to streamline the machine learning lifecycle and enhance collaboration between data scientists and engineers. Whereas human capital, I would focus on establishing a center of excellence for machine learning, embedding data scientists directly within business units, and offering training programs to enhance overall data fluency in the firm. For the deployment and governance, this is our final stage, which focus and addressed deployment and its accountability, where we have to take care of two things: phase deployment and governance. I recommend a structured approach for phase deployment that includes three phases: pilot, scale, and dominate. This ensures a gradual, controlled, and successful integration of machine learning into core company processes. Governance: this requires establishing a data and ML governance board. This board would oversee compliance, conduct necessary bias audits, and ensure transparency and accountability are built into all AI practices while mitigating all the risk factors of stealing the data or any kind of unethical practices that is been going on. Coming up in the next slide, we have part 2, Austin Animal Center data analysis. Now transitioning into my first case study, the Austin Animal Shelter dataset. The goal was to predict animal outcomes. The primary objective is to develop a predictive model that can forecast the outcomes of animals in the shelter based on various attributes. For that, the dataset is substantial, comprising 95,367 records collected from 2013 to 2020, providing a rich source of information for the analysis. And for the tools, I have used Python, Jupyter, Pandas, NumPy, which are powerful for data manipulation and analysis. To pre-process and analyze the data efficiently, I have used NumPy and Pandas libraries. So in this case, I have done data pre-processing of the dataset. Data preparation was extensive. I focused on 3 key areas: removal attributes, retained key attributes, and converted age upon outcome to numeric month. The first one, in the removed attributes, certain attributes such as animal ID, name, month, year, and date time were deemed and unnecessary for the analysis were removed to streamline the dataset for the efficient results and better performance of our model. The retained key attributes, where I retained 7 key attributes including date of birth, animal type, and outcome type, which I believe are critical for predicting outcomes, because from date of birth, age matters and animal type is also mattering. Now, when I critically used this converted age upon outcome, the age upon outcome attribute was transformed from its text representation into numeric months. For better analysis and modeling. So these were the 3 key attributes I have used to pre-process animal shelter data. Coming up to the next slide, for handling missing data and final dataset, I have also addressed missingness of the data using a combination of techniques such as removal, dropped record, imputation, file missing values, and final structure, which shows 7 clean features. Now removal dropped records. The records, those were missing critical attributes such as date of birth, animal type, or outcome type, were removed to ensure data integrity. Missing values for categorical attributes like sex, breed, and color were filled with unknown, while age upon outcome months was filled with median values for the imputation purpose. This process led to final structure 7 clean features, where our dataset final dataset consists of 7 clean features that are now suitable for modeling and analysis. I have saved this data set as animal shelter cleaned CS in the CSV file. Now coming up to the next slide, regarding abalone regression setup, which is my second study and which is very important for the regression problem. The goal is to predict abalone age. The objective is to accurately predict the age of abalones based on their physical measurements, which is represented by the number of rings. And for this, the data I had, which contains 4,177 records, 4,177 records. The data set contains mix of numeric and categorical features, providing a diverse set of data for analysis. Pre-processing involved cleaning the columns, separating numeric and categorical feature, and applying transformation for modeling. For this, I can show you the code from Jupyter Notebook. Which is this here, where first I imported all the necessary Python libraries. Then I had to define the correct headers. They were not, column names were not assigned. Then I checked for missing values, and here I created pre-process pipeline. Then I trained the model, random forest model, then predict on test data where RMSE was 2.26 and R square score was 0.53. Then I output, you can show 10-fold cross validation output, and then defined a new data for the abalone, and also predicted the new age for those records. And for this, in this code that I showed you for abalone model and training, I had problem of supervised regression model into random forest regression using pipeline designing. The task is framed as supervised regression problem where the model I learn from labeled data to make predictions. I employed random forest regression, which I chose because it is known for its robustness and ability to handle complex tasks with the relationships in the data. My design utilized a pipeline. This model design includes a pre-processing pipeline followed by the random forest model, ensuring a streamlined workflow and preventing any kind of unnecessary data leakage. For the robustness and efficiency of our random forest model. Now in this slide I have displayed abalone results. The model demonstrated moderate predictive power. The test performance RMSC was 2.26 rings. The model achieved a root mean square error of approximately 2.26 rings, indicating the average deviation of predictions from actual values. The R square was near 0.53. This means the model explains about 53% of the variance in the data, demonstrating a moderate level of predictive power. And for example predictions, the model estimated a smaller male abalone at around 12 rings and a larger female at approximately 15 rings, illustrating model application. Now, another important part of this presentation is car evaluation clustering model. For this, I have performed an unsupervised learning task. The goal is to discover car segments. The aim is to identify distinct segments of car based on their attributes without prior labels to guide market analysis. The data consists solely of 7 categorical attributes, providing a rich basis for clustering analysis. And for this dataset's pre-processing, I applied a one-hot encoder to transform categorical features into a high-dimensional binary feature space which is very suitable for clustering. One hot encoder is also very efficient for clustering. After this, now coming up to the car clustering model and its results. The problem type was unsupervised clustering. This task is framed as unsupervised clustering because the model identifies patterns without labeled data. I employed the k-mean algorithm with 4 clusters to segment the data into 4 distinct clusters based on their attributes, where the outcome were the learned cluster centers. The model identified 4 cluster centers representing different car segments, which allows for targeted marketing and analysis. Now coming up to the last slide of this presentation and the third most important case study of adult income classification, where the goal is to predict income threshold. The objective is to classify individuals based on whether their income exceeds a certain threshold, providing valuable insights for decision making. The features are both numeric and categorical for this analysis. The dataset that includes features such as age, education, and occupation, which are critical for classification. For pre-processing, I performed a train test split and applied standard scaler for the numeric features on one hot encoder for categorical features to prepare the data for modeling. In summary, this project has covered the full scope of a modern data science engagement, from defining a robust enterprise ML strategy to the execution of 3 major ML paradigms: regression, unsupervised clustering, and the last one, classification on diverse data sets, with the operation of pre-processing of data cleaning. The diversity of these case studies demonstrate my ability to select and apply the appropriate techniques, manage complex pre-processing pipelines, and evaluate models against relevant matrices for varied business problems. Thank you so much, everyone, for being patient to hear me out this much.